Uh, Good evening. This is David De Los Reyes. It's February 7, 2022. We are here in Los Angeles, California. Okay. I am now on lesson 28 on integral calculus on my channel. This is the topic, integral calculus. We are running smooth. We are on lesson 28 on the topic integral calculus. We are done with differential calculus. So we are almost going to the application problems of integral calculus. We are only familiarizing ourselves with the different integrations. Okay? Okay, let's proceed so we don't waste time. The topic for tonight is integration of hyperbolic functions. Hyperbolic functions. I will give you the first four formulas, but since our board is not enough, I will just give you only two plus the derivation of the two because it is a long simplification. But the next time around for the next four, it's shorter. Okay? Okay, let's proceed with formula number one under hyperbolic functions. The integral of hyperbolic secant square of b dv equal to hyperbolic tangent of b plus c. Second, the integral of hyperbolic cosecant square of b dv equal to hyperbolic cotangent of b preceded by negative sign, that is, this is plus c. The third one, the integral of hyperbolic sine of b dv equal to hyperbolic cosine of b plus c. Fourth one, the integral of hyperbolic cosine of b dv equal to hyperbolic sine of b plus c. Okay, I will give you the derivation of the first two. It's a long one because it involves a numerator and denominator, and it involves a sum, okay? But when we go to the hyperbolic sine and hyperbolic cosine, it's shorter, okay? So for tonight, I will just only give you the derivation of hyperbolic secant square and hyperbolic cosecant square, okay? Okay, let's proceed. Before proceeding with the derivation, let us recall under exponential equivalence, hyperbolic sine of x is e to the x minus e to the minus x over 2. That's the equivalent of hyperbolic sine in terms of the exponential equivalent. Hyperbolic cosine. Hyperbolic cosine of x is e to the x plus e to the minus x over 2. For cosine, this should be plus. For sine, this should be minus. Okay? So it's just a matter of recalling it. Okay? And hyperbolic tangent is hyperbolic sine over hyperbolic cosine. We will just divide these two here. Okay? So these two here cancels. So what will remain for hyperbolic tangent of x is e to the x minus e to the minus x all over e to the x plus e to the minus x. Why did I give you these ones? Because in the derivation, okay, we will use the differential of an exponential functions to derive hyperbolic function. Okay, let's proceed with number one. To derive equation number one, we will let y equal to hyperbolic tangent of x. And hyperbolic tangent of x is actually this one. It's a little bit complicated. It's not complicated, it's just a simplification. So y will be equal to, if hyperbolic tangent of x, in terms of exponential equivalent, it will be e to the x minus e to the minus x over e to the x plus e to the minus x. Okay, to bring out the formula, let's proceed with taking the differential of both sides. So the differential of y will be the differential of y, and the differential of the right hand side, it involves a numerator and denominator. I just designate that the numerator is e to the x minus e to the minus x, and the denominator is e to the x plus e to the minus x. And if we try to recall the formula and how to take the derivative of a quotient, it will be the denominator times the differential of the numerator minus the numerator times the differential of the denominator all over the denominator square. Sorry for that one. Then for us to be systematic, let us compute for the differential of the numerator and denominator separately before we will substitute to the formula. Okay? So the differential of the numerator will be the differential of e to the x minus e to the minus x. Taking the differential of the right hand side, it will be e to the x times dx. Okay? Minus e to the minus x. The differential of minus x is minus dx. Okay? It's negative. So simplifying, we will bring out the common factor dx. This is dx. So it will be e to the x. Okay? This is minus minus. So this should be plus. E to the minus x. Close quantity dx. So this is the equivalent of the differential of the numerator if we take the differential separately. Okay, let's proceed with taking the differential of the denominator. The differential of the denominator equal to the differential of what is the denominator? E to the x plus e to the minus x. Proceeding with the differentiation or taking the differential, it is e to the u times the u. So this is e to the x times dx plus e to the minus x times the differential of the exponent. It should be negative dx. Okay? We will continue here. The differential of the denominator now will be e to the x. Okay? This is plus, this minus. So this should be minus close quantity dx. Okay? So to bring out the value of dy, we will follow this. Right? We will substitute the value of the differential of the numerator, the differential of the denominator back here. It's just a matter of substitution. So the denominator is e to the x plus this. The differential of the numerator is actually this one, e to the x plus e to the minus x times dx. Right? We got a dx here. I bring it out, okay? Minus the numerator, minus open quantity denominator. This is the numerator. This is the differential of the denominator. This is e to the x minus e to the minus x times the quantity e to the x minus e to the minus x. We got a dx here. I bring it out already. Okay? All over e to the x plus e to the minus x quantity square. Right? So if we try to expand this one, the numerator, just be very careful because one wrong side, we cannot derive the formula. So if we try to simplify this one, I did it myself already. E to the 2x plus e to the minus 2x plus 2 minus 2 minus e to the 2x minus e to the minus 2x plus 2. Okay? This one cancels. This one cancels. Same exponent. Positive, negative. This is 2x, this is 2x. This positive, this negative, so they cancel out. 2 plus 2 is 4. Okay? That is actually 2 squared. And e plus e to the minus x quantity square. This is actually, the bottom portion got a square. But I simplified that the numerator is also, the numerator is 4. So I could put it under one fraction, then quantity square. Right? But this is 1 over cosine. Oh, this is cosine. 1 over cosine. And cosine is the reciprocal of secant. So actually 2 over e to the x plus e to the minus x is a hyperbolic secant. Therefore, dy now, the integral of dy now, if we take the integral of both sides, 2 all over e to the x plus e to the minus x is hyperbolic secant. Okay? So this should be hyperbolic secant square of x dx. Taking the integral of both sides and rearranging, hyperbolic secant square of x equal to the integral of dy. This cancels out. So it will just be simply y plus c. But what is y? Y is hyperbolic tangent of x, right? So the integral of hyperbolic secant square of x equal to hyperbolic tangent of x plus c. To be more general, if x is equal to b, the integral of hyperbolic secant square of b db should be hyperbolic tangent of b plus c. That's formula number 1. It is this. Okay? So just in case you got a problem in which they are asking for the integral of hyperbolic secant square of b db, the answer should be hyperbolic tangent of b plus c. Okay, let's proceed with derivation number 2. For derivation number 2, we will let y equal to hyperbolic cotangent of x. And hyperbolic cotangent is the reciprocal of hyperbolic tangent. Okay? So this should go up, the plus should go up, and the minus should go down. Okay? So y will be e to the x plus e to the minus x over e to the x minus e to the minus x. It is the reciprocal of hyperbolic tangent. That is hyperbolic cotangent. Okay? And this is similar to the form numerator over denominator. I let the numerator to be e to the x plus e to the minus x. Denominator is equal to e to the x plus e to the minus x. Why did I do that? Because I want to solve for the differential of the numerator and denominator separately. Okay? So I make a designation. Taking the differential of the numerator, it should be the differential of the quantity e to the x plus e to the minus x. Exponential function, it should be e to the x times dx plus e to the minus x times minus dx. We factor out the x. Okay? The sign of the second term should be minus. This is plus, is minus, so this is minus. So the differential of the numerator taken separately, e to the x minus e to the minus x, closed quantity times dx. Separately, okay? We are just being systematic. Let's try to compute for the value of the differential of the denominator. The differential of the denominator is equal to the differential of e to the x minus e to the minus x. Again, exponential function. We are through with that. Don't be afraid. We know the differential of e to the u. It should be e to the x times dx minus e to the minus x times minus dx. Right? Okay? We factor out the x. The sign of the second term should be plus. This is minus, so this should be plus. So the differential of the denominator taken separately, it will be e to the x plus e to the minus x, closed quantity dx. Okay? So we now know the value of the differential of the numerator, the differential of the denominator separately. Okay? Oh, I became more systematic. I took the product of this and this again separately. So it's a nice thing. We are going downward, right? So the denominator times the differential of the numerator is e to the x minus e to the minus x times the quantity e to the x minus e to the minus x times dx. And if we try to simplify this one, this is the value. Okay? I took the product of this as separately, okay? Then we will compute the product of the numerator times the differential of the denominator again separately. Okay? E to the x plus e to the minus x times the quantity e to the x plus e to the minus x dx. And if we try to take the simplification of this, it is this. Right? So if we try to substitute these values here, back to this equation here, it will be e to the x plus e to the minus x minus 2. It is this. Minus open quantity. E to the x plus e to the minus 2x plus 2. Close quantity. I bring out the common factor dx over here. All over the common denominator e to the x minus e to the minus x quantity square. Actually, if we try to expand this one, e to the x cancels. The power is 2x. This is plus, this is minus. This is minus 2x, this is minus 2x. So actually we can combine. This is plus, this is minus, it cancels out. Right? So minus 2 is minus 4. I put the negative as negative side here already. Why only 2? I put it under the exponent 2. Because 2 squared is 4. 2 and 2 is 4, right? I bring out the negative side. And this is e to the x plus e to the minus x quantity squared. So actually, I factor out the right-hand side by making 2 over e to the x minus e to the minus x quantity squared. And this is actually 2 over this is actually hyperbolic cosecant. Then, taking the integral of both sides, okay, we got the negative sign over here. So to remove the negative sign on the left-hand side, we multiply this by negative 1. Right? Negative, negative, this will now be hyperbolic cosecant square of x equal to the integral of dy times negative 1. This will cancel out. Y times minus 1 is minus y. This is plus c. But what is y? Y is hyperbolic cotangent of x. This is negative. Okay? So, to bring out the more general form, if we let x equal to b, therefore, formula number 2 now, the integral of hyperbolic cosecant square of b, it's not x, it should be b. So, it could take any function, form of function, equal to hyperbolic cotangent of b, negative, plus c. That's formula number 2. The differentiation is easy. It's just that the simplification is a little bit long. So if you are not systematic, okay, you will be writing maximum on the horizontal thing instead of the vertical thing. So we just did it to be systematic. So actually, we write vertically downward, so the writing on the board will be okay. Okay? So this is formula number 2. This is formula number 1. The next time around, we will try to bring up the derivation of hyperbolic sine and hyperbolic cosine plus the last 2. Okay, that's it for tonight, guys. If you like it, please click like. If you want to share it, please click share. And if you want to subscribe, please click subscribe. For those who are interested in learning integral calculus, okay, in a concise and straightforward manner. Good evening, Los Angeles.